So now that we understand some of the language involved in this topic, it's time to look at what happens when you start changing some of the values in a quadratic that make the parabola shape. You can see that we have the y equals x squared parabola, the very first one we looked at, and also the second one we looked at, y equals x squared plus x plus 2. They're in red and green on the screen. So what we're going to be doing is I'm going to get rid of the red one and we're going to focus on this green one here, because the point of this part of the lesson is to look at, well, what happens if I change certain numbers or certain values, and how does that change the shape of the parabola? We know that as long as it's got an x squared and nothing higher, no x cubed or x to the 4, as long as there's nothing higher than an x squared, it will make a parabola. So within that parameter, we can change whatever we want. For example, if I take this x squared plus x plus 2 and I put a number in front of the x squared term, like a 3, you can see it has an immediate effect on the shape of the parabola. You can see it's made it thinner. Or if I choose a number smaller than 1, say 0.5, it makes it wider. For now, I'm just going to put the value a there, and I'm going to add a slider a. And what that means is whatever it shows underneath, where it says currently a equals 1, then that's what is going to be put into the quadratic relation. So if I change that to 2, it shows you what happens there. So if I press play on that, you can see the bigger that number gets, the thinner the graph gets. And vice versa, if it gets closer towards 0, it gets wider. When it gets negative, it flips upside down. It makes that concave shape that we talked about last class. So then moving on to the next term, the x term. If I put a number or any kind of value in front of the x term, like the 3 again, you can see that also changes the parabola. It changes it in a different way. It shifts it across and it shifts it down or up. So if I make a B slider, I call it A, B, and C, you can see here that as that number gets bigger, it goes further downwards and a little bit to the left. And if it sort of gets back in the other direction, you can see what it does. It kind of traces out a shape of a parabola in itself. So this last term, this plus 2 on the end, the 2 could have been anything. I just chose that number last video. But if that was a 1 or a 3, you can see what's happening here. If I change it to a 3, you can see the point where the graph crosses the y-axis is now at 3. If I change it to -5, you can see that it crosses the y-axis at -5. So putting different numbers and different values in different places in this quadratic relation changes not the graph. It's still a parabola, but it changes specific characteristics of the parabola. So I might make it wider or thinner, or I might move it across or up or down. And that's useful for us to know when we start looking at real-world applications. Here's a picture of the Sydney Harbour Bridge imposed over the XY axis. And you might be able to see some parabolas already in that bridge shape. If I try and make an equation to fit that rule, the basic one is y equals x squared, and it kind of looks nothing like the curve that we're aiming for. You can see the way that the bridge is curving. It's actually curving the opposite direction. Right now I have a convex. That bridge is clearly concave. So I know I have to make, wrong spot. I have to make that negative for it to be a concave curve. Now I can see it's too low. So I need to raise that just a little bit. So what if I pick 1? It's still a bit too low. 2 seems to be maybe a little bit too high, but 1.5 seems to suit it okay. So now the next step is, well, we have to make that graph wider. Now we learned by messing around with it earlier that to make it wider, we actually have to change the value in front of the x squared. It's currently at a -1, and we learned that if we want it to get wider, we have to reduce the number. So we have to make it smaller than 1. So if I pick 0.5, you see it gets a little bit wider, but not quite enough. So if I pick 0.05, that looks much better. It's starting to look almost exactly like that curve of that bridge. And the point of this exercise is to show you that parabolas aren't just a mathematical principle. They exist in the real world. Let me show you another example. So no doubt you are familiar with the game Angry Bird. We have a screenshot from it here superimposed on the graph, and I've got quite a complicated looking equation underneath. I'm not going to go through picking and choosing all the different values and numbers, because you can see the equation, the blue one there. It's not quite on where the path of the parabola goes, but it's pretty close. And you can see some of these parabolas could be quite fiddly to try and get just right. they didn't really come out of nowhere, but it took a lot of playing around and guessing. So I knew roughly what I needed to do. I knew that if I made it negative, I'd get the right concave. I knew that it was a bit wider than the typical graph, the red one here. So I had to make the coefficient of the x squared term a bit smaller than 1. And it's just a matter of guess and check, fiddling with those numbers until you can find a curve that pretty much fits the one we're after. Finally, I want to show you this last example of a car headlight. There's actually two diagrams on the graph here. We're going to ignore the telescope mirror one on the left just because the car headlight one is already centered around the XY axis, around that origin point there. So it's going to be easier to talk about. Now, concave and convex shapes, parabolas, are very handy in real world situations because they enable us to be able to do practical things with them. I'll show you the equation that we've got here modeling it. So that y equals 0.11x squared. We've made the shape a little bit wider. And you can see this cone shape, this convex parabola, is the shape of the inside of a car headlight. Now, the practical application of this is you can see the bulb in the middle there and those arrows, those gray arrows. Those are the light beams or the light rays being emitted from the light bulb. All of those beams reflect at a different point off that parabola, and they all reflect in the exact same direction, and that's extremely useful for driving in nighttime because all the light is directed directly in front of you at the road. So not only are parabolas seen in the real world in terms of bridges or video games or things like that, there's actually so many different applications that can be useful. For example, this car headlight.